Here next slide will be a second types of band brake. So first type of band brake is simple band brake and second type is differential band brake. So it is similar to simple band brake, but in differential band brake the extension of lever at a certain angle introduced in differential band brake. Please see in a figure here. So in a simple band brake, a straight lever used as O to C, but in differential band brake we use a extension of the lever at a certain angle as OA is the extension of the lever. So here the ends of bends is fixed at point A and point B on the lever A, O, B and C. Okay. Please see in the figure, tension T is perpendicular to the lever OC, and here tension T is perpendicular to AO. Okay, please wait. Okay, please see. Here tension T is perpendicular to AO, and here T is perpendicular to OC. Okay. The main important thing is the length of OA must be greater than the length of OB. This is the main consideration for differential band brake, and different terminologies used as simple band brake conditions. So here T1 is tension in tight side, T2 is tension in slack side, theta is angle of lap of bend over the wheel, mu coefficient of friction, small r is equal to radius of wheel or radius of drum, T is equal to thickness of bend, Re effective radius of drum including bend thickness. So Re is equivalent to R plus T by 2. So this is very important. If thickness of bend will be considered, so Re will be used as R. So Re is equal to R plus T by 2. Okay. Now as similar conditions, limiting ratio of tension forces T1 upon T2 is equal to e की power mu theta, total effective braking force F is equal to T1 minus T2, and braking torque will be as previously TB is equal to T1 minus T2 into R. This is used for when bend thickness neglecting, and when we consider thickness of bend, so we will use TB is equal to T1 minus T2 into R plus T by 2. These formulas are similar as simple bend brake, but different in taking the momentum equation or generating the momentum equation. Now in bend brake or differential bend brake, we have condition of rotation of wheel. First condition, when wheel rotates in clockwise direction or when wheel rotates in anti-clockwise direction. First see when wheel rotates in clockwise direction. This is the figure for wheel rotation in clockwise direction. Okay, so please see here in this figure, wheel rotates in clockwise direction, wheel rotates in clockwise direction. So in this case, band will come from this side or enters from this side. So this side will be tight side and here tension is T1, and the band leaves from this side and this side will be slack side and having tension T2. Okay, this is very important. So length from OA, length between OA is small a, and length between OB is small b, and length between O to C is L. Okay, now see in a figure this. Please take a moment about point O. So P into L, it's make a clockwise couple. So clockwise couple makes a positive sense, P into L. And next couple will be T1 into B. It's also make a clockwise couple. So it will also be positive sense, T1 into B. And T2 into A, it's make a anti-clockwise couple. T2 into A, it's make a anti-clockwise couple about point O. So it will be negative. So P into L plus T1 into B minus T2 into A equal to 0. So we got P into L equal to T2 into A minus T1 into B. This relation. Okay. P into L is equal to T2 into A minus T1 into B. If in this equation T2 into A equal to T1 into B, in this equation T2 into A equal to T1 into B, that gives right hand side will be 0. That means P equal to 0. That means no external force required for braking. So if no external force required for braking, this condition is known as self-locking. Or another way, if T1 into B greater than or equal to T2 into A, that gives right hand side value negative or 0. That also gives P equal to 0. So P is equal to 0, that means no external force is required. So this condition is used for self-locking condition. So in next step we write it here. Condition for self-locking. Condition for self-locking is T1 into B must be equal to or greater than T1 into B must be equal to and greater than T2 into A, or T1 upon T2 must be greater than or equal to A upon B. If both conditions satisfied, the condition is self-locking. So please here see the above condition will gives the value will be negative or 0. Okay. Now moves on when wheel rotates in anti-clockwise direction. In this figure, wheel rotates anti-clockwise direction. So band will enters from this side. So this side, entering side, will be tight side and having tension T1, and leaving from this side, and where band leaves, that side will be slack side and tension will be T2. So when wheel rotates in anti-clockwise direction, taking moment about point O, P into L makes a clockwise couple. It will be positive. Next couple T2 into B, it's also making a clockwise couple. It's also positive. And T1 into A, that's make anti-clockwise couple, so this will be negative. So we get P into L plus T2 into B minus T1 into A will be 0. The moment of sum will be 0. So P into L plus T2 into B minus T1 into A will be 0. So we simplify this. We got P into L equal to T1 into A into T2 into B. Okay. Please see in this equation, if T2 into B will greater or equal to T1 into A, T2 into B will greater or equal to T1 into A. This gives the value of right hand side will negative or will 0. So if the value of right hand side will get 0 or negative, that means P will be 0 or negative. That means no external force required for braking. So this condition is also known as self-locking. So please see here, condition for self-locking, T2 into B must be greater or equal to T1 into A. This condition is for self-locking. So it is simplified as T2 upon T1 must greater or equal to A upon B. If both conditions are satisfied, or either one or two conditions are satisfied, so condition is known as self-locking. Okay, please note it down. For self-locking condition, the value of P will be 0. So in this case, P will be 0. That means T2 into A equal to T1 into B. This is condition for self-locking when wheel rotates in clockwise direction. And for using this relationship, here P is equal to 0. That means T1 into A is equal to T2 into B. This will be equation for self-locking when wheel rotates in anti-clockwise direction. Okay. Please note a very important formula using differential band brake or simple band brake also. Note, torque TV is equal to load into radius of pulley. If extra pulley is attached to a rotating shaft with a load W, so please see in this figure, if this is a rotating wheel and this is a rotating shaft axis, and having a extra pulley on the rotating shaft. This is wheel or drum, or this is pulley. So in the pulley we attached a load, that we assume W, or we say load W. So in condition of rotation, W into radius of pulley, this is the radius of pulley. So we know the torque, load into radius of wheel, so that must equal to load on pulley or multiply by radius of pulley. So please see, torque must be equal to load on pulley into radius of pulley, capital R. So here we very carefully use radius of pulley, not use radius of wheel or radius of drum. Okay, I hope you will be understand. Thank you for watching.